are with the BYOC Mega Chorus Vibrato. And this is it. This is what it's gonna be anyway. See on the other side. And oh my, 27 pages. This one should be fun, huh? Oh yeah, I was asked by a friend, actually just the other day, what, you know, if a cheap soldering station is adequate. There's mine, the Weller WES51, very industry standard type soldering iron. There you go. Get a good one if you do a fair amount of soldering. I had one really bad weekend one time where I went through 2 of them. Not the Wellers, but cheap ones. What's the old saying? Cheap ain't cheap. Buy nice or buy twice. And on the subject of tools, you can never really have enough. There's my 3 main sets of needle nose. You know, long and skinny, everyday use, and well, not that these are big, but these are, you know, for working on a soldering project like this. Those are a little bit big and meaty. Okay, so the first thing it says is, once again, break off the little tabs on the pots. These little guys right here. See that okay? I'm still getting used to the new camera angle. So that little guy right there, it just snaps right off. And why do we do that? Well, so that the potentiometer will flush mount just nicely when it goes into the enclosure. Another handy dandy tip, where do you keep your tools? Well, me, I keep a lot of them on an old speaker magnet. It just hangs from the rafter up there. Super convenient, because actually, I don't know if you can see that there, I got one of those bar magnets at one time to hang socket drivers, as you can see. Those bar magnets are expensive. The speaker costs nothing, because you just go find an old blown up one out of the garbage. Okay, once again, we're going to start with the resistors. Same board as always from BYOC. Good, nice, thick, high quality, very easy to read, as long as it's not glaring. Very well labeled, super easy. Okay, now partway through just inserting the resistors. Another good reason not to solder anything until you know you have all your parts. This little guy here, you only get 156K resistor, and where it says 3207 and 3007 here, it depends on which chip you're using here. So the one that was supplied is the 3207, yeah, the 3207, which maybe you can see it if your eyes are better than mine, but that's what it is. So what it says is, what we're going to do is put the 56K resistor here in the 3207 slot, leave the 3007 slot empty, and then when we get over here to, when we start putting in jumpers, we're going to make a jumper here where it says jump, and then we're going to jumper the spaces for the 3207 and leave the 3007 empty. So that'll make an interesting video for later. Maybe I'll find me a 3007 chip after the honeymoon wears off and swap it out. Maybe that'll be another interesting video for down the line. And there we are. All the resistors populated onto the board. Time to do some soldering. It's funny. It's noticeably heavier. Populated with resistors. Yay! Okay, time for the diodes, which are be, for example, here, here, and here. So there's two types of diodes. The 4001, this guy, the bigger one. Oh, hey, look, you can kind of read that. So you see how the stripe is on the left side? Stripe. It's right here on the PC board. There we go. Thank you to the kind folks at BYOC for making that nice and clear. So the 4148 are the smaller little guys, and we probably won't be able to focus in on those, right? But you can see the black stripe is on the left side. And of course, the stripe corresponds to that spot and that spot on the PC board. There's 5 of them. See you after. Okay, now we are going to solder in the sockets for the ICs. Not the IC, the socket for the IC. So you'll notice on the PC board, there's a little notch here. That's for orientation, because they will not work properly if you install them upside down. Here's the socket. There's a little notch that corresponds to the notch on the PC board. Notice top side here is flat, bottom side has a notch. So pop them in like so. Solder them on the other side. Everybody's happy. There we are, sockets installed. Starting to look a little bit more populated. Next step. Okay, the next step is going to be the transistors. And they are all 3904s. They look like this. And you'll notice they have a flat side on the face and the rounded side in the back. So on the PC board, all these little locations will have a flat side, and well as they can do with rounding on a PC board. And it even says 3904. Nice and handy. The only exception being right here, upper left hand. I've flipped it over so you can see it. It says VREG, that's the voltage regulator. And in the kit, that is the only one with a little piece of tape that doesn't say 3904 on the face. So we'll put those in and be right back. Okay, time to put in the trim pods. It's actually the next day. I had to go get some sleep. So there's 2 trim pots. They look like so. There's a 25K and a 50K. They are marked on the trim pod itself. Can you see that? 203, and the other one is marked 503. The 203 is the 25K, the 503 is the 50K. You notice there is 5 through holes, but only 3 leads on the trim pot. Do that so you can put different types of trim pots in, but there's only one way you can insert it. See, there's 1 lead on one side. That's the wiper. Only one way you can put it in. There you go. And there they are installed. So these are trim pots. You adjust them with a little screwdriver, like so. And they suggest that we start, in the center we'll be adjusting these by ear after we are up and running. Okay, so now it's time to put in the capacitors. So we have the electrolytic capacitors here in blue, and the film and ceramic caps, we'll call them caps from here on out, in brown. So the film caps and the ceramic caps don't have polarity. It doesn't matter which way you put them in. They do have values which are a little confusing for people at first. Like this one, for example, 222. The values are not the easiest things in the world to read. So this one, if you can see that, it says 63 volts, that's its power handling capability, and 105K. 105 is its code, and to me the easiest thing to do is just pull up, you just Google a handy dandy capacitor chart, something like that, on the internet, if you are interested in finding out what the codes mean. This one in particular corresponds to this same one here, corresponds to 1 microfarad. It's the biggest of the film caps that they give you in the kit. The other way to do it, of course, is to just look at the picture. There's not very many values, and it's pretty easy to figure out which is which if you're going by the picture, and you can do the same thing that you did with the resistors. You see the one, you pop all the biggest ones in, double check yourself against the picture, and go from there. And just in case it wasn't so clear before, the code is let me see, where's the code here? That's what's written on the capacitor, and what's on the board is microfarads. So show you here. For example, this one here says 0.47. What it's going to look like on the, I'm watching for light. What it's going to look like on the board is 474. So it's going to say 0.47 on the board. The capacitor is going to say 474. Like this guy here. Sure I did this right. Yep. 0.47 on the board. The capacitor says focus 474 with a little K behind it. On the board, let me get this bad boy kind of closer. We'll have a square pad and a rounder pad. The square pad is positive. That's where the longer lead goes. And once again, you can always double check yourself by looking at the picture. And that's what mine looks like so far. And in the instructions, it says if you're building to 3207 spec, which we are, it should look like this. It is worth it at this point to just double check a few little things. For example, make sure the polarities are correct on your diodes. Make sure your transistors are facing the right direction. Make sure your polarized capacitors are facing the right direction. There is, if you can see, there is even a little plus sign on the positive side of those caps. So the negative side is marked here, the positive side is marked here on the board. And just do a quick rundown, quick double check. Another thing, we've got a lot of solder connections now, and the board is still quite free and easy to move around. Just run around and double check, make sure you don't have any solder bridges. That is one of the main things that you will find if you have trouble and you have to do troubleshooting. You're going to run through and find solder bridges, because these connections can get, fairly close together. Okay, and the next step is the battery clip. They call it the battery snap because those are kind of like little snaps. I'm not a huge fan of batteries myself, but just like in the last video, they made this pretty easy. So positive and negative. Negative obviously is black. They have this built-in little strain relief where the wire comes up like so, and then pop it in like so. Solder from the bottom side because it's the same side that everything else is soldered on, right? Solder like so. Pull out the slack, and you have your handy dandy little strain relief, so you're not pulling directly on a solder joint, which would over time certainly lead to disaster. Alright, now we're going to start soldering the wires, the jumpers that go from the board to various places, such as the pots, that kind of thing. Outside of the board, they give you the handy dandy purple wire to do this with. In the instructions, they tell you to wire up, or to make jumpers to specific lengths. I found them to be very accurate. So I'm going to make some wire jumpers. And if you didn't see it in the previous video, come on now. I have to show you my favorite tool of all time. The Klein Catapult for wire stripping. It is the handiest, dandiest wire stripper ever. With that, pretty self-explanatory, right? Pick your gauge of wire, pick your little jaw, squeeze, and that's it. That's all there is to it. Okay, there it is with all the jumpers going to the pots, external spots. It's starting to look like Cthulhu, I guess, at this point. So at this point, talked about the pots go on this side of the board like so. Do not put them on this side of the board. A, they don't fit. B, that's the wrong side of the board. So it's going to mount into the enclosure like so. And when you flip the enclosure over, you'll flip the bottom of the board over. That is the correct placement. So, once you solder the pots in, you won't be able to get underneath them to clean up all the excess flux, which is something I like to do at this point. You don't want flux on your board if you don't need it. So just a little bit of alcohol and some Q-tips, and we'll be back. Okay, now we're going to remove all of the nuts and washers and these plastic covers from the pots. I've yet to do one of these, so I'm going to experiment a little and then show you what I come up with. And truly they do. You just cut a little slit in the side. I actually I used my plier cutters, but they will just pop right off. No problem. Okay, so we'll set aside lots of washers. So what I did, you don't want to solder anything into place yet. I just installed them and bent the leads just enough so they won't fall out. You want to double check your values. The potentiometer values are marked quite clearly up on top, and the picture is quite clear on the instructions. Now for some reason the LED is in the bag with the knobs. So the LED will have a longer lead for the positive side, and if you look inside here, Short lead has the larger little structure inside. That's the negative side. So the positive side, once again, goes to the square on the PC board. Now remember, we don't know yet how tall this is going to be. This is likely going to be, you know, somewhere up here as far as mounting height. So what I'll usually do is just kind of set it somewhere around where it's going to be, and just bend the lead so it doesn't fall out, and we can work with it until we get it into the enclosure. Don't solder anything yet. Make sure that everything fits into the enclosure. So just kind of get them to fit. There we go. As well as you can. Guide them in. It's not the easiest thing in the world with this many pots. But it'll eventually snap into place. Everybody's fairly happy. Make sure you have enough room. See, this is the LED leads. Make sure you've got enough play to get the LED. Yep, the LED looks like it's going to fit in there just nicely, so I've got enough lead there. Okay, so now we do not want to solder anything to place yet, but we just want to finger tight all the nuts onto the pots. Like so. And I'll get those all on and be right back. Now we're going to solder the PC board in place. Now you wanna lift the board up just ever so slightly. Just so that the bottom of the pots here, this level, doesn't short out anything on the underside of the PC board. So you just kind of watch where your contacts are here. Obviously, don't pull the board completely off of all your pots, because then you'll have a whole lot of redoing to do that you don't want to do at this point. And there we go, all soldered into place. Nice and snug and firm in there. Now we can tighten up all these nuts. Next thing is going to be the power jack, and I'll show you my handy dandy little trick with that in just a second. Okay, so wiring up, go with that, there we go, wiring up the power jack. You notice they show tip, sleeve, and battery. They don't go into a whole lot of detail about what that means. I've grabbed my handy dandy DS1, and if you can see that there, the tip is negative, the sleeve is positive. This is very standard Boss style wiring. So what we're going to do is wire up tip and sleeve with black and red jumpers, and then the one that they call battery with a purple jumper. And they're pretty clearly marked on the PC board though. Tip negative on the left side, sleeve positive on the right side, and battery in the middle. I should mention, don't forget to remove the nut before you install it into the enclosure. And here we are with our color-coded wires, making it very easy to remember what's what. A bit idiot-proof. Okay, that's what it looks like when it's done. Now we're going to install the input jack, which is the stereo jack. Two contacts there. Make sure you put the input jack on the input side. The output jack on the output side. Yeah, you spin it around a little now. Here's from the last video. A little something to remember. When... Here, let me put this on quick. Okay. When the plug goes in, like so, right? It pushes the leaves out a little bit. So you want to make sure, I don't see anything that's going to get in their way, but see they're going to flex out a little bit. So make sure that nothing's going to get in their way. My previous build had to reposition because the leaf actually hit the PC board itself and didn't let the plug go in all the way. I think we're going to have that issue with this one. I think. Yeah, we got lock washers with this. I'm going to put a lock washer on there just to make it a little more sturdy. Alright, now we're going to wire up the jacks themselves and the switch. The switch is always got some fun switchy-ness to it, so let's get everything out of the way. Here's the switch. The switch isn't polarized, but there is an orientation for it. You'll notice the lugs are kind of sideways here. The holes go through this way, so the lugs are like so, or like so. So horizontal, vertical, as we're looking at them right now. When you pop it in, sure it will have. Ooh, that they don't give you very much clearance there. Between there's enough. There's plenty, so it's not a problem. But you're not going to be able to install it and decide that you want it in another direction and spin it while it's in there. So you'll want to orient it correctly. I believe this is it. I think you want it, as we're looking at it like this, I think it's going to be horizontal. Yes, that is correct. Okay, there it is, all wired up. We did have to make 2 more jumpers between the jack and the switch here and here. They could have told us that when we were making those 7 4-inch versions. But, you know, whatever. No big deal. There it is. We're going to put the ICs in and then fire it up. Alright, so installing the chips, they could have actually made this a little easier. These two here, they don't actually give you very good diagrams. You gotta go back to the picture, and you can see all it says is right there. It just says dual op amp right here. That's what it says on the board. The dual op amps are the 4558s. Here and here. The TLO22, thank heavens, is marked. The 3207 is marked. And the last one just is clocked, so it's the last one left, so that's where it goes. Not marked well, but not terrible to figure out. Okay, all completed. There's the internals. So it looks like on the outside. I've got it hooked up to my bench amp already. So the first test I like to do is to just see if the See if the LED fires up. So plug it in here. Plug in the jack. Oh, look at that! And it fires up. Throbbing. So the speed control rate, that's up here. Oh, look at that. Even doing its thing there. Alright. You can hear it. A little bit. Plug it into the guitar. First time. What do you know? And believe it or not, that's a result. Yeah, shape, I'm not sure what that is yet. Depth. Yep, and I'm sure we've got a little bit of tweaking to do with the trim pots, but what do you know? Okay, so adjusting the 20K, 25K trim pot is surprisingly easy. It started out about in the middle. It says you just do it by ear. You just strum so you hear less distortion. There's quite a bit of distortion there. Just back it off just a tiny bit there. It's a little hard to hear. Through the controls a little bit. It's sine wave. Oh, getting a little more distortion now, so let's go back through. See what those, see if the 50K does anything. Delay. Oh, blend. There we go. Haha. Went too far with the trim pot. Now we're back. Okay, here's the finished product. Running into my trusty little Savage amp. Hopefully a little bit better audio quality this time. Here's what it sounds like, just a hint of reverb running into the amp. Here is the chorus. Okay, we'll run down the settings just as they are in the instructions. First is blend, controls the ratio of wet vibrato signal to dry signal. And it's this guy right here. Center. Me, I'm a little subtle guys. Back down there. Okay. Depth. This one right here controls the intensity of the wet vibrato signal. Let's turn them up. You've already heard them coming down. So as you can hear, it's pretty out of control. Rate, they're calling it speed, but we'll call it rate like it says. Controls the speed of the LFO, and you'll be able to see this with the speed of the LED. Okay, tone. It adds high frequencies to the wet signal. The wet signal only shouldn't affect your dry signal. Turn it all the way down. All the way up. Okay. Right back to the middle. Delay controls the amount of delay time produced by the BBD. So, turn them down a little, let's turn them way up. It's pretty out there. Okay, shape changes the shape of the LFO. Counterclockwise produces a saw wave, bends the pitch up faster and down slower. Clockwise produces a ramp wave, bends the pitch up slower and down faster. Well, try it all the way down first. And all the way up. Okay. I'm going to set that one back in the middle, tone in the middle, rate somewhere around so. Get it back to a kind of a little bit more of a normal setting. The sine triangle switch changes the waveform between sine wave and triangle wave. So far, the up position is sine, the down position is triangle. So far you've just heard sine, here's triangle. And back. Nope. There's the audio demo. Hope you like it. Friend, did you like the audio demo?